from the area of a region under a curve, which I told you is what we've been doing, to the area of a region between two curves. Consider two functions f and g that are continuous. On the interval a to b. Also, the graphs of both f and g lie above the x-axis. And the graph of g lies below the graph of f as shown in the first graph below. So if we look at the first one, f is this curve right here, the darker one, g is the lower one, so it is underneath, but they are both above the x-axis. You can geometrically interpret the area of the region between the graphs as the area of the region under the graph of g subtracted from the area of the region under the graph of f. Everybody good? Let me give you a minute. Okay. While he's copying that down, what you can't see on this paper are the shades. So the area between f and g on the interval a to b, the area that we're trying to find is this little shaded area right here. This is the area under f. You can kind of see, well, how about I do that right? Would be all of this. And then the area under G would be this area. So what it's saying is we're going to take this full area under F, subtract this bottom area that we don't want, and that will give us our little area in between the curves. Okay, so same thing that you've been doing. There's nothing any different. We're just going to subtract two integrations. Good. So to verify the reasonableness of the result shown above, you can partition the interval A to B into n subintervals, each of width delta x. Then, as shown on the following page, sketch a representative rectangle of width delta x and height f of x sub I minus g of x sub I, where x sub I is the ith subinterval. It sounds complicated as not. Don't stress out about it. Ready, good. So there's your representative rectangle that they're talking about. You're going to go from some point on f of x and some point of g of x, and that will be your height. And then your width is going to be that delta x, whatever you decide that delta x is. So the area of this representative rectangle so delta A sub I is equal to the height times the width. And you already know that because rectangle is length times width. They just use height on this one. Which is the same thing as f of xi minus g of xi times delta x. All right, so where does this come from? Like I told you, they pick a point on f of x, and it's going to be the y coordinate, so that's why it's f of xi. Okay, so the y coordinate, because we're talking about height, and a y coordinate on g, and subtract that to get what this height is. That's exactly how you get the height anyway. How far apart are these 2 points? And then you want to multiply it by delta x, because delta x is the width. So that's all it is. It's the same exact formula, height times width. This is how you get the height. This represents the width. Same formula. By adding the areas of the n rectangles and taking the limit as delta approaches 0, which is the same thing as n approaches 0. You're going to obtain the limit as n approaches infinity of the summation from 1 to n of that formula that we just wrote. F of x sub I minus g of x sub I times delta x. Because f and g are continuous, on that interval a to b, f minus g is also continuous on AB. And the limit exists. So the area of the region is area equals the limit as n approaches infinity. Yeah, absolutely. No worries.
Yeah.
No, the back page, is it the stuff for today?
Yeah.
The back page, I don't have a key on there because I just added it. The summation from 1 to n, same thing that we just wrote a second ago, f of xi minus g of xi delta x. So remember a while back, we did limits and then we changed that limit. So this was really hard, finding the, doing the integration, finding the area by the limit. And then we learned integration. So we used integration after that. So instead of using the limit definition, we can do the integration from a to b of f of xi minus g of xi delta x, not delta x, dx, sorry. So this is what we're going to focus on. We don't have to do the limit definition. We can just do the integration. Did you find it? You good? Okay. You're perfectly fine. Any questions? Is everybody good? All right. So the area of a region between two curves. If f and g are continuous on a and b and g of x is less than or equal to f of x for all x in a, b, then the area of the region bounded by the graphs of f and g and the vertical lines x equals a and x equals b are the same thing that we just wrote. So again, we're going to start using area equals the integration from a to b, and that's the interval that they give us. So between the two x lines, a and b, of again, f of xi minus g of xi dx. You can also change that to just f of x and g of x. So in the first figures, the graphs of f and g are shown above the x-axis. This, however, is not necessary. The same integrin that f of x minus g of x can be used as long as f and g are continuous. And g of x is below or less than f of x. And that would be for all x in the interval a to b. This is summarized graphically in the following figure. Notice that the height of the representative rectangle, so you guys can see that rectangle in the bottom. To find it, you would subtract your y coordinates, which are f of x and g of x. So f of x minus g of x, regardless of the relative position of the x-axis. So it doesn't have to be above the x-axis. It can be below it. That's fine. And you're still going to do the same thing. Representative rectangles are used throughout this chapter in various applications of integration. A vertical rectangle, which is all you've seen right now. So those two figures have vertical rectangles. Have a width of delta x, implies integration with respect to x. But you can also have a horizontal rectangle. How would it change? It's going to have a width of what? Delta y. Because we're going to take integration with respect to y. Everybody good? All right. Finding the area of a region between two curves. Find the area of the region bounded by the graphs of y equals x squared plus 2, y equals negative x, between x equals 0 and x equals 1. So this will be your a and your b interval. Okay. A and your b interval. If we graph these, give me 2 seconds. You guys have a calculator. That was graph one. Too much, but we're going to be plugging in values, so you're probably going to use it. All right, so you have your two functions, x squared plus 2 and y equals negative x. Remember, we want f of g above g of x. I mean, f of x above g of x. Has everybody got that? So we need to figure out which one that is. So my x squared plus 2 is going to graph blue The other one's going to graph red. Whichever one's on the bottom is going to be g of x. On top is f of x. So when I graph it, ooh, what do you see? Did I put in the right thing? I did put it in. Well, but it's still the area between. We're okay. They just don't overlap. So what you're looking at, you're going to have this and that. And we're just looking for between A and B, sorry, y'all, just that area. So they don't have to overlap like they did in the notes. So in the other pictures. So which one is on top? So that's going to be your f of x. This one, negative x, is on the bottom. So it's going to be your g of x. Sorry, I squished the negative in there. I'll make it so you guys can see it. So I'm going to write that back down here. We're choosing f of x is x squared plus 2 because it's on the top. And g of x equals negative x because it's below. So our formula says that the area is going to be f of x minus g of x delta x. Ooh. What is f of x? X squared plus 2 minus g of x is negative x. Everybody see that? Delta x. We're going to simplify this a little bit more. It gives us x squared plus x plus 2 delta x. Negative negative makes a positive, and then I'm going to put it in order. Everybody okay with that? Good? Everybody good? All right, so then to get A, we do the integration from A to B of f of x minus g of x. I will not write this every single time, but I want you to know where everything comes from. What is our A and what is our B? 0 to 1. Remember, your littlest one always goes on the bottom. What did we get for f of x minus g of x delta x? And then we just throw a dx on the end. Now we integrate. This is the same thing we've been doing. So there's nothing any different. The only difference was to find my function first that I needed to integrate. I had to subtract. So now how do I integrate x squared plus x plus 2? And we're going to plug 0 and 1, so I don't need the c because I'm doing a definite integral. Do you remember how to do this when we have 0 and 1? Plug in 1, subtract, plug in 0. Well, when I plug in 0, what's going to happen? Everything is going to cancel out, right? So this time I only have to plug in 1, but typically you want to plug in 0. So I'm going to do that. When I plug in 1, what do I get for this first fraction? When I plug in 1, what do I get for the second fraction? When I plug in 1, what do I get for the third part? And then I would plug in 0, plug in 0, plug in 0. This would actually be a minus. Just so you understand where it's coming from. And then you put in 1/3 plus 1/2 plus 2. And you're going to get 17/6. So this is your final answer. And again, I just wanted to write this so you guys could see that I did plug in 0, but we don't have to because everything is 0. Right? And that's it. So that's as hard as it gets. The integration, whatever you're integrating, is going to be the hardest part. This was easy function, so it's really quick. I think on the notes, all of them are pretty easy functions. So area of a region between intersecting curves. So these didn't intersect. The ones in the beginning of the notes did. So now we're going to do intersecting curves. In example 1, the graphs of f of x equals x squared plus 2 and g of x equals negative x do not intersect. And the values of a and b, sorry, there's a gap right there I'll fix, are given explicitly. A more common problem involves the area of a region bounded by 2 intersecting graphs. Where the values of a and b must be calculated. So it says a region lying between 2 intersecting graphs. Find the area of the region bounded by the graphs of 2 minus x squared and x. So if we graph these functions, notice that they have 2 points of intersection. So we're going to talk about this. We're going to graph them. I have 2 minus x squared and just x, and I'm going to graph. So they look like this. I'm going to go ahead and draw this up here for you guys. So that's what it looks like. So they have these 2 points of intersection right here. To find the x coordinates of the points that f of x and g of x equal. So remember, not all of your exam is calculator active. So this is how you would do it if you don't have a calculator. If you do, put them into your graph and do your second trace intersect. Okay, find them or look at them. Is everybody good? So if not, you're going to set them equal to each other. We get 2 minus x squared equal to x. Since I have x squared and x, I need to get it equal to 0 and then factor it. Again, things that you should know because you've been doing that since like math 1. So long time. I'm going to move this x squared over and the 2 over. So we have a positive x squared plus x minus 2. Again, I just moved the x squared and the 2 to the other side. When I factor this, what are your factors of negative 2 to add the positive 1? 2 and negative 1. So your 2 intersections or your 2 x coordinates are? Negative 2 and positive 1. These become your A and your B. Your A is your smallest. Your B is your larger number. So which one is A? Negative 2. And which one is your B? That's it. So A equals negative 2 and B equals 1. Because g of x is less than f of x. So remember, g of x was the straight line is below the curve. For all x in the interval, negative 2 to 1. The representative rectangle has an area of so delta A. How did we find delta A? Go back up to the top. How do we find delta A? again, you don't have to write this all the time. All we're doing is subtracting our function. So I just want you to know where everything comes from. So which one is f of x? And we're going to subtract, what was g of x? X. Before I do integration, I like to put them in order. You do not have to. Everybody understand that? You can leave it just like this and it is perfectly fine. There's nothing really we can simplify, but I like to see mine in order. So I do negative x squared minus x and a positive 2. You do not have to put them in order. So very good. All right. So the area of the region is, how did we find the area of the region? What did we have to do? Integrate from where to where? Negative 2 to 1 of what? What do I have to put on the end of that? Yeah, just dx. All right. So when I integrate that, what am I going to get? Oh my gosh, who's Snapchat? Who is it? Can we just turn it down? Does anybody know who it is? No, we don't know. It's not really bothering me. I just didn't want y'all to feel bad. I don't care. Yeah. It's all good. Don't worry about it. Don't worry about it. I'm not that teacher. I just want y'all, you know, if it's gonna keep happening, obviously, but that's right. And how? 'Cause, I mean, y'all shouldn't have your phones, right?
Sierra's right here, so it's like I get notifications from other.
Yeah, I
classes.
forget about like, I mean, I just assume y'all just have friends here. I don't even think about it. There it is. All right. I didn't know if it was coming in through somebody's watch and they knew who it was and they could turn it off. I don't care. It's not really bothering me. It just makes me laugh a little bit. All right, what do we do now? I'm going to tell you the easiest way to do this, because these are whole numbers, is to put this function into your y equals instead of having to plug it in and screw everything up. Now, if you can't use your calculator, did I not show you how to plug it in the first one? Yes. So what I would do is I would go into y equals and put this function in, and I'm going to use alpha y equals so that I don't screw it up. Negative x to the third over 3 minus x squared over 2 and then plus 2x. And the reason that I'm going to do this again is because I have that negative and then I'm plugging in a negative 2 cubed. So I don't want to screw up my negatives. Okay. Is everybody good? Then I'm going to go to my table. If it's auto or if it's ask, you can find it because they're whole numbers. If yours happens to be on ask, you're plugging in negative 2 and 1. If not, which one do we do first? Which one comes first? The 1, right? So we're doing big minus little. So what is your value for 1? And then we look for our value of negative 2, which is? So this is actually 7/6 plus 10 over 3. You can, again, do this in your calculator if you'd like to, but I can make common denominators to be 7/6 plus 20 over 6, or 27 over 6, and then I can reduce it to what?
14 over 2. Maybe. No, it's close. No, it's 9 over 2.
9 over 2.
It's 9 over 2.
It is. I wrote it up there.
Okay,
Calm
okay.
down.
It was close to 14. Okay.
You almost had it.
So a 9-year-old is close to 14?
What?
A 9-year-old is close to a 14?
Oh, yeah.
Not anywhere near. a fifth grader compared to a freshman in high school? Not
I don't
close.
know, they're not that much.
You're about right.
I don't know.
Fifth grader might be more mature than ninth
I'm
grader.
really down the hallway right there every day. Every day I yell, excuse me.
Compared to now, freshman,
Maybe you should not yell, excuse me. Maybe you should say, excuse me.
I don't know if I was
Okay.
a freshman, I was just blind to it. Were we like that? I feel like we were not as bad. We didn't do stuff like that. Some of them looked like they were supposed to be in like third grade. There's
You're older than me, and that says a lot.
Hunter
oh
will
yeah,
like that.
one is walking right next to me, and they're like down here, and I was
And then it's like, oh my gosh.
Y'all were like that.
I'm in the same high school. There's not much I can.
You have not looked the same since fifth grade.
Oh, no.
You have changed.
But I don't know about that.
I know for sure I didn't.
Her face looks the same. Her face looks the same. But she didn't have that body in fifth grade. She didn't have that body in ninth grade.
No.
All right.
Emily,
I
you
don't
can't say
know.
anything.
Cindy. You've always just like me.
Oh, stop.
She does.
All right. A region line between two intersecting graphs, the same thing. The sine and cosine curves intersect infinitely many times. Bounding regions of equal areas shown below. Find the area of one of these regions. So which one are we going to use for f of x and which one are we going to use for g of x? It doesn't tell you, I mean, it does, it can, but which one would you choose for f of x? The dark one, because it is. No. It's above, thank you, it's above. So f of x is gonna be which one? Sin x. G of x is gonna be the cosine x. If you get this on a test, it may not have this graph, it's probably not going to. So you have to determine which one is which. Again, you would graph them and see. All right. So what else do we have to find? Do they give us A and B? I'm gonna ask one more time. Do they give us A and B? How did we find that? Say it again. Yeah, how do we find them if we don't have this graph? Set them equal to each other. Just like the last one, what did we do? Got it all equal to 0. So how did I do that? You could, but I would rather you divide it. Why would you divide it? Why'd you say divide? So let me divide it for you and see if you see anything.
How does dividing work?
Because they're just like regular, like if you had x equals y, you can put them over 1 and cross multiply, or you can divide the y over. It's fine. It all works out. I promise. What happens when you do that? Oh, sine over cosine is what? Tangent. And this is 1. This keeps us from having to do trig identities. We could also square the other side, like if we subtracted it or whatever, square it, and we can get the 1. So don't stress out too much. We're just going to move it over. All right. Do we know where tan x is equal to 1? We could also do sine equal to cosine if you have your calculator, but this is if you don't have your calculator. How would you figure that out? Nobody knows. We're using sine, cosine, and tangent. What else can we use? Where are they based off? Oh my God, how do you get the values for X and Y and sine, cosine, tangent? It's a circle? Yeah, the circle, the circle. So that was cute. That was cute. Yeah, the unit circle. So how do we do that? Yeah, you definitely need to know that. You should have known that in pre-calc. All right, so let's go to our unit circle. I'm gonna show you, not with that paper. Don't stress out. Again, this is if you don't have what? A calculator. We can change it on our calculator from radians, degrees to radians, whatever. We can figure out what it is. So if we're looking at this, I'm gonna go back over here. This is the front of your book too. This is not a secret. Your tan is y over x, your y coordinate over your x coordinate. Okay, I need to get 1. What does that mean? If I want to get 1, y over x to be 1, what does that tell me? They need to be the same, right? Okay, so let's look. Where are they the same? Pi over 4. One more. 5 pi over 4. Why are the other ones not? The signs are different, right? So we're going to look where they're both the same. So pi over 4 and 5 pi over 4. That's your answers. Those are your A and B. So from the unit circle, tan equals y over x. You need x and y the same to equal 1. And that's at pi over 4 and 5 pi over 4. If you need to write x and y coordinates to be the same, then you can write that as well. All right, so we're going to find the area. We're going to go ahead and write our integration. Which one's littler? Yeah. Of pi over 4, 5 pi over 4. What's your f of x? Minus, what's your g of x? And what do we put on the end? Dx. And now your book, we'll put it in parentheses or brackets like this, just so you know you're taking the, or the derivative of both, integrating both sine x and cosine x. Right? What's the integration of sine x? Minus, what's the integration of cosine x? Sine x, and we're going from pi over 4 to 5 pi over 4. Again, if you don't have a calculator, you have to use the unit circle. I'm going to show you how to do that again. We're getting not super close to AP exam, but we're getting close, right? So we need to remember how to do that. If you do not get the unit circle on the exam, can you draw it out? You should be able to. We will review that again before you guys take the exam. Unit circle is pretty easy. All right. Let me go back to my unit circle. Maybe we stick it together. If you look, cosine is the x. Cosine is the x. Sine is y. Is everybody good? All right. And we're only looking at pi over 4 and 5 pi over 4. So what do you notice about both of those? So the 5 over 4 is going to be negative square root of 2 over 2, but everything is square root of 2 over 2, right? Everything is square root of 2 over 2. So your two coordinates for pi over 4 is positive square root of 2 over 2. 5 pi over 4 is negative negative. And what did I just tell you? Cosine is going to be your, which coordinate? X or Y? Okay. And look again, so you trust me. Cosine is X over R if it's a unit circle with a radius. If it's a unit circle with a radius. One. So that's why we don't worry with the R. Does everybody understand that? So be over one. All right. So cosine is your X coordinate. Sine is your Y coordinate. Lord, mercy. All right. Which one do we do first? Point. The big one. So negative. Which one would be cosine X or cosine 5 pi over 4? So go to 5 pi over 4 and we look at the X coordinate. So what do we get? Okay. Minus. We're doing 5 pi over 4, but this time we're doing sine 5 pi over 4. Sine is your, but they're the same. So it's still going to be negative square root of 2 over 2. So this is your first one of 5 pi over 4. Now we have to subtract and we have to do pi over 4. So it's the same thing. Negative cosine pi over 4 is going to be the X coordinate of pi over 4, which is square root of 2 over 2. Minus sine is going to be the Y coordinate, which is still going to be square root of 2 over 2. So then we're just going to fix our signs and simplify. So a negative negative makes a positive. A negative negative makes a positive. Over here, a negative negative makes a positive. A negative negative makes a positive. What do we actually have? Don't even reduce it. Tell me what we have. How many square root of 2 over 2's do we have? 4 square root of 2's over 2, which reduces to that's it. That's it. All right, so don't forget your unit circle. And like I said, we'll go over that before we take the exam. So don't freak out if you're like, oh my God, I don't remember it. Use your book for now. If you get sines, cosines, tangents, anything like that, use your book for now. And then, like I said, we'll go over that unit circle. We are not very far, and I know this is going to sound crazy because it's January. We are not far from reviewing for the AP exam. Does everybody understand that? Okay, not far at all. So to find the area of the region between two curves that intersect at more than 2 points, first determine all the points of intersection, then check to see which curve is above the other. In each interval determined by these points as shown in the following examples. What?
Here's what I set in my phone.
She got her
refresher in that
old
cup, frappuccino in that cup, and a sweet tea in my car, so it'll be cold when I get out.
All right. Find the area of the region between the graphs of f of x equals 3x cubed minus x squared minus 10x and g of x equals negative x squared plus 2x. So what do we do? What's the let's talk about this a little bit before we start like yelling stuff out. What's the difference? Like, what have we been doing this whole time? Of? What was f of x? I'm not talking about this problem, just in general. The one that's on top, right? And g of x is? So when we look at this problem, what happens? Yeah, so in one little part, one graph is on top, the other one is on the bottom, but then in the next part, those two interchange, right? So guess what we have to do? We have to do it twice. We have to find the area of the first curve and then the area of the second one. It's the same thing, yes.
So then why didn't we do that on the other one?
Why didn't we? We were only finding what? One. We were only finding the one
Just
area.
'cause they put the box there, that's how we know we're on the
It said only found one. Sorry. That wasn't me being crappy. Like literally, it just said find one. It says it does it many times, but we only want one.
Okay.
If we went back to that problem and they said find three, what would we do? Just multiply it by three because it's the same thing. This one is a little bit different. Sine and cosine keeps the same wave. These don't necessarily keep the same one. So that's why it's a little bit different. So they intersect infinitely many times. So how many ever times it says find four of them, find one and then multiply by four. But on this one, we can't do that because if you look, the two areas are definitely different. Okay, but so we found the area of the first side, like that left side, and then we found the area of the right side, and then what would we do to them? If we want the total of both areas, you add them. Okay, so subtract with him, and then once you find both of them, add. So let's start with the first half. So I'm gonna put a little one right here, and then I'm gonna put a two over here. Okay, so we're gonna find the area of the first one. Which one is our f of x? Mhm. So 3x to the third minus x squared minus 10x. And our g of x is? What did I do to those? No. Not yet. I don't need to do that on this one. Why? They already gave me the points of intersection. So yes, on a typical time when they don't give you the graph, absolutely set them equal to each other so that you can find A and B, but we don't have to this time because they give them to us. The question is, what do I do to find the actual area? What do I have to do to these two functions? Subtract them. So we're going to do f of x minus g of x this time. Why do we do f of x minus g of x? F of x is on top, g of x on the bottom. So the next one that we do, what are we going to have to do? G of x minus f of x. Got it? That's it. So that's the only difference in doing this. And then you add the two together. So the first one that we're going to do is 3x cubed minus x squared minus 10x. And then we're going to subtract negative x squared plus 2x. I'm going to simplify, distribute all at the same time. Our highest power is x cubed, so we have 3x cubed. We have a negative x squared right here. When I distribute my negative, I get a positive x squared. So what happens? They cancel out. And then I have negative 10x minus 2x. If you set this equal to 0, you will find those two intersections. Everybody got it? Very good. All right. What do we do now? From where to where? You could have said 0 to negative 2. Just remember to put the lowest one on the bottom, negative 2 to 0. What's your integration? From negative 2 to 0. You're gonna make it. What's wrong? Oh, You probably ground zero. Spreading all this nastiness.
I promise you.
I'm just kidding, I'm just kidding, I'm just kidding. Calm down, just kidding. All right, I'm gonna go ahead and simplify 3x to the fourth over 4 minus 6x squared from -2 to 0. How do I find out the area? I'm gonna be lazy and use my calculator. 3x to the fourth over 4 minus 6x squared. And I'm looking for -2 and 0, but the first one I'm gonna do is 0. Minus, and then I'm gonna do, I'm sorry, yeah, -2, which is -12. Which gives you what? +12. Now I'll do the second one. What changes about this one? So we're going to keep the same f of x, but the problem is that they interchange positions. So this time we have to subtract f of x from g of x. So g of x is -x squared plus 2x. I'm going to subtract these, which means I just change all the signs, right? So I'm going to go ahead and do that right now while it's here to save some space. 3x cubed, we're going to subtract. We're going to add x squared, and we're going to add 10x again, because we're just changing the signs. What happens? We're left with -3x cubed plus 12x. We're going to do that integration from where to where? When we go back to our graph, they intersect at 0 and 2. What does that mean I will have? From 0 to 2. Remember that this is the same thing, -3x to the fourth over 4 plus 6x squared from 0 to 2. So in my y equals, add that negative in, and this changes to positive. We're looking at 0 to 2. Which one do I put first? The 2. So what was it, 2? 12. Minus, what's my value at 0? Which gives me, how do I find the total area? So total area equals 12 plus 12, or 24. Your book, when you look at the example, it literally does it all together. I just winged it and did it separate so that you guys could see it a little bit. I like it better separate. Okay, I like it better separate rather than all together. All right. In the last example, notice that you obtain an incorrect result when you integrate from -2 to 2. Such an integration produces, so here's what it's saying. If you try to do it as one whole, instead of splitting it into 2, f of x minus g of x dx, you would get the integration from -2 to 2 of 3x cubed minus 12x dx. And that would actually give you 0. So you can't do it all together. You have to do it separate. When the graph of a function of y is a boundary of a region, it is often convenient to use representative rectangles that are horizontal. And find the area by integrating with respect to y. In general, to determine the area between two curves, you can use that the area is the integration from x1 to x2, your smallest x coordinate to your largest x coordinate, of the top curve minus the bottom curve dx, or the integration of your littlest y to your biggest y. So if we're going y, instead of doing top to bottom, we would do what? Horizontal would go left to right, right? So which one's your bigger one? The right. Right curve minus left curve. Oh, dy. Where this says x1 comma y1, x2 comma y2. So your coordinates x1, your first x and y, and your second x and y are either adjacent points of intersection of the two curves involved or points on the specified boundary lines. All right, horizontal representative rectangles. On the area of the region bounded by the graphs of x equals 3 minus y squared and x equals y plus 1. So do they give us an A and a B? How do we find A and B? Set them equal to each other. 3 minus y squared equals y plus 1. Solve it just like it were x. Don't make it any different. How would I do that? Oops, sorry. Move both the y squared and the 3. So we get 0 equals y squared plus y. And in this case, we'll have minus 2. Is everybody good with the minus 2? Subtract 3, 1 minus 3 is -2. Same thing as the last one that we did, that we had to do this. Factor it how? What are your factors of -2 that add to 1? And we get that y equals -2 and +1. All right. What about these graphs? Let me do this for a second. Sorry, everybody that's watching the thing, it went to black screen for a reason. It's not cut off yet. Let me show you guys this real quick. You should know what these look like, but I want to show you anyway. There's x equals 3 minus y squared, and then y plus 1, like this. Everybody see that? When we're doing horizontal, which one do we put first? Which one is f of x in this case? The one on the right. So which one is on the right? Yeah, the red is the furthest to the right. When you're talking about this area right here in between the curves, the one on the right is going to be the red one. On the left, it's going to be the blue one. So 3 minus y squared. And I'm going to go back to this page. And g of x is the line, or y plus 1. So should just on screen, but it'll be okay. So your f of x is the one on the right, and your g of x is the one on the left. What do I do now? So area equals the integration from -2 to 1 of 3 minus y squared minus y minus 1 dx. Why is it minus y minus 1? Because we're subtracting it, so I just distributed the negative. I'm gonna clean it up. Have negative y squared minus y plus 2 shouldn't be dy, it should be, shouldn't be dx, it should be dy. I apologize. But you work it the same exact way. What is my integration? And we're going from -2 to 1. You can treat these like x's in your y equals if you're using your calculator. It is perfectly fine. Does everybody understand that? It's still the same thing. You're just looking at a different variable. So what will you plug in first? 1. So we would get -1 cubed over 3 minus 1 squared over 2 plus 2 times 1 minus, and then we'll plug in -2, -2 cubed over 3 minus -2 squared over 2 plus 2 times -2. Again, or you can do it in your y equals and look at your table. And it will come up to be 9/2 as well. At the bottom of this, it showed you those 2 curves. I did not have to graph them, but I didn't want you to look at those so that you weren't tempted to answer based on the graph. This is if they don't give you the graph. So in this last example, notice that by integrating with respect to y, you need only one integral to integrate with respect to x. You would need 2 integrals because the upper boundary changes at x equals 2. So that's what it's trying to show you. I think we can finish. If not, we'll do the last question on Tuesday, if we're here. Integration is a accumulation process. In this section, the integration formula for the area between 2 curves was developed by using a rectangle as a representative element. For each new application in the remaining sections of this chapter, an appropriate representative element will be constructed using pre-calculus formulas you should already know. Each integration formula will then be obtained by summing. What is summing? Adding or accumulating these representative elements. So you will have a known pre-calc formula that will give you a representative element so that you can have a new integration formula. For example, the area formula in this section was developed as follows. So that says A equals the height times the width. Then we did delta A equals f of x minus g of x delta x, because that was our representative element, which gave us our new integration formula, which is not new, of a to b or from a to b of f of x minus g of x dx. So this next example is not like a work it out example, is to show you how it works. You can figure out the work it out process yourself. It's really simple. Okay. So I'll explain what I'm talking about in just a minute. Find the area of the region bounded by the graphs of y equals 4 minus x squared and the x-axis and describe the integration as an accumulation process. So the area of the region that we're looking for is going to be the integration from -2 to 2 of 4 minus x squared dx. You can think of the integration as an accumulation of the areas of the rectangles formed in the representative rectangle slides from -2, x equals -2 to x equals 2. So this next part is where I'm going to give you areas. We're not going to do the work to find those areas because you already know how to find the integration. So to make it an accumulation process, you start with your smallest and go to that smallest. So -2 to -2 of that 4 minus x squared dx. What would be the integration of 4 minus x squared? And then what would you do? Plug in -2 minus, plug in -2, right? What happens if you're minus and plugging in the same thing? It's going to get 0, right? So your first one is going to be 0. Then you just go up a unit. So from -2 to -1. So we're just going to keep creeping up by 1. Same thing, we would have, sorry, I started thinking about it. 4x minus x cubed over 3. And then we would plug in -2 minus plug in -1. And when you do that, you get 5/3. So we're not doing the work to find the area is what I was trying to explain to you earlier. But can you? Yes, it's pointless for us to keep doing that. What would be my next interval from -2 to what? 0 of 4 minus x squared dx. And I will go ahead and tell you if that gives you 16 over 3. We're not doing the work for it. And this is the accumulation process that they're talking about. So then where would we go? -2 to 1 of 4 minus x squared dx. This would give us 9. And then remember, we're trying to get to 2. So this will be my last one. And that would give me 32 over 3. And that is it. You do not have any homework, will not have any homework. If we come back on Tuesday, we'll review this a little bit together with homework questions. Okay, everybody good? Oh, that's not